Hey, ladies and gentlemen, today we're going to talk about special right triangles. Today we're going to work at just the 45, 45, 90. And then on Wednesday, you're going to be hearing about the 30, 60, 90 as well. But today we're going to work on 45, 45, 90. So here we go. So real quick, when we talk about 45, 45, 90, if you kind of think back to our unit on triangles, a 45, 45, 90 looks like this. So if both base angles are congruent, then we also know that the sides are also congruent. So it's an isosceles right triangle. So that just means, like, say, if this side is 3, this side also has to be 3. Those sides are equal. And since we've got right triangles, if the two legs are congruent and your two angles then down here have to be congruent, and they're just always going to be 45, 45, 90. Like, they're always going to have the measures of 45, 45, and 90. Okay, so we're going to use Pythagorean theorem to help us out here, but then we're going to kind of come up with our own rule a little bit as well. Because remember, in my class, I always like to kind of give you the background on the rule and not just give you the rule. So we're going to say, hey, if one leg is 1 and the other leg is 1, let's figure out what the hypotenuse is. So if I do 1 squared plus 1 squared, that's going to be equal to my hypotenuse squared. 1 plus 1 is just 2. And then to get rid of the square, we're going to take, the square root of both sides. And we're also going to keep these in terms of a simplest radical form. So our hypotenuse here is going to be just the square root of 2. Now, if I have sides of 2, let's do the same thing. 2 squared plus 2 squared is going to be equal to our h squared. So 4 plus 4 is equal to our h squared. H squared then is equal to 8. When we take the square root of that, let's go ahead and simplify the square root of 8. So square root of 8 breaks down into 4 and 2, and then we have 2 and 2. So we have one set of repeats. So I'm going to write that once. And then we have one that's not circled, so I'm going to put that underneath. So the square root of 8 is just 2 square roots of 2. Alrighty, let's go ahead and erase some of this stuff to give us some more room. Okay, so let's do 3 and then 4. So if one leg is 3, the other leg has to be 3. And then let's go ahead and do 3 squared plus 3 squared is equal to that hypotenuse squared. So 9 plus 9 is 18. When I take the square root, let's simplify 18. 18 is just 2 and 9, and then 3 and 3. So I have one set of 3s, so I'm going to write that once. The 2 is not circled, so I'm going to put that underneath the square root symbol. Now here, I want you to kind of pause and think for a little bit. Do you see a pattern? And what patterns do you see? And can you figure out what this should be without doing your Pythagorean theorem? Okay, so one leg is 4 and the other leg is 4. Hopefully you have an idea of what that one should be, but let's go ahead and use Pythagorean theorem to help us out. So if I have 4 squared plus 4 squared, that equals our hypotenuse squared, 16 plus 16. So that gives us 32 is equal to our hypotenuse squared when we take the square root of both of those. Okay, so we get 2 and 16. We get 4 and 4. We could keep going, but I already see a double here, so I'm not going to. So that's going to be 4 square roots of 2. And hopefully that's what you recognized. So if you notice, again, we're going to think about it here. We can do a pause. What do you notice that's the same in all of them? And then what do you notice? Can you think of a reason, or can you figure out how we get the number in front that is different? Okay, so if you notice, they all have a square root of 2. And so your hypotenuse length of any 45, 45, 90 degree triangle will always have a square root of 2 in it. And while this one doesn't have a number in front, we can say it's like an invisible 1. So we have 1 square root of 2, 2 square roots of 2, and so on. And this number in front here is just the measurement of the leg. So whenever we have a 45, 45, 90 degree angle, or a 45, 45, 90 degree triangle, your legs are going to always be the same. And then your hypotenuse is always your leg times the square root of 2 every single time. Okay, so let's go ahead and write this rule down. I'm going to write it a couple different ways. So we have a leg and we have a leg, and those legs will always be equal since it's an isosceles triangle. And then we're going to always have your leg times your square root of 2. Sometimes you might see this written out more, oops, there we go, like this, where you have like an A, and then we have another A, and then it's going to be like an A times the square root of 2. So that's our rule. Now let's go ahead and use this rule a little bit and do some examples. Alrighty. So for this one, we have a 45, 45, 90. We know that's because we have the right angle and it says 45. You might also have congruency markings here and here that would tell you that those sides are equal. So since my legs are equal, n has to equal 8. And then my hypotenuse is just my leg times the square root of 2. For this example over here, my legs are equal, so y is going to be equal to 9. And then my hypotenuse is just my leg times the square root of 2. Now, if you have a really hard time memorizing rules and you don't want to, you could just do Pythagorean theorem and then simplify it if you'd like to, since we did learn how to simplify radicals last week. Alrighty, now going the other way, when you're given the hypotenuse. So here, officially when we're given the hypotenuse, since our hypotenuse is the leg times the square root of 2, we can just divide both sides by the square root of 2. When we do that, so we do 9 square roots of 2, divide by a square root of 2, those cancel out and become a 1, and we're just left with the number that's in front. So A and B are going to be equal to each other, or just be 9. Here, same thing, 11 square roots of 2. If I divide through by a square root of 2, those become a 1. So then X and Y are both going to be equal to 11. If you have like a square root of 2, you can kind of just look at the front number. That's what the measurement of your leg is going to be. And that's as far as we're going to go with it in this class for this year. If you have any questions, please message me. And that is it for today.